In this video, I'm going to be sharing a really nice problem that was conceived by Dietmar Kuchmann, whose name I may have butchered slightly, but is also known as Professor Smudge on his various blog posts that he writes. This is a collection of blog posts known as Algebradabra, from which I drew this problem. Professor Smudge also has a collection of other blogs he's written over time that also relate to algebra, as well as some that focus mostly on geometry. I would recommend all of them. You can find them by tapping on his name here. I will link to this in the link below the YouTube video, as well as on my blog post. And if you're interested in purchasing any of these materials as books, the Association of Teachers of Mathematics of the UK has published a number of his blog posts, all collected together in, I think, 4 or 5 books. So, on to the problem itself. Look at this triangle. What happens to the shape of the triangle as x changes? And notice we have one angle that's measured x degrees, and this other angle is measured 2x degrees. Now, I've seen various problems where they mix some algebra with geometry, and the geometry always seems to get the short end of things because it's really just an excuse to do some algebra. So another very common problem might be if this angle is x, this is 2x, and this is 3x, what's the value of x? Again, not really much geometry going on there, just solving for x. Well, here with this problem, there's nothing to solve for. In fact, what got me really interested in it is that it's really a dynamic geometry problem. What happens to this triangle as x changes? So I'm going to be building this with Web Sketchpad, but I would not recommend watching that part of my video yet. I would stop the video and do what I did, which is to think about it and visualize what you see as x is increasing. What happens to the shape of the triangle, the size of the triangle? Is there any limit on the value of x? Think about it in your mind, maybe draw some pictures, and when you're ready, let's go and build this triangle and see if your visualizations actually pan out. So I'm going to be building this triangle using, no surprise, Web Sketchpad. On the blog post itself that accompanies this video, you'll find this sketch with these 6 tools. I didn't have it ready yet for myself in the blog post, so I just quickly built it using the Web Sketchpad tool library, which I highly encourage you to explore as well. So let's get started. I'm going to use the segment tool, and let's just construct one side of our triangle. So here we have it. I'm going to use the label tool, which I'll scoot out of my way a little bit, to label these 2 points, which will be 2 vertices of my triangle A and B. Now for the second side, I really don't know how long it's going to be, but I'm going to start by just constructing an array, starting at B, and I don't really care where this other point goes. This is going to be my angle x, and since x can vary, I'm going to be varying it by dragging this point, which, while we're at it, let's label it as C. So here I'm going to be constructing an angle that's twice the measure of ABC, but to do that I actually need to know the measure of ABC. So let's use the angle tool. I'll tap on that. I see a preview of an angle and its measure. And let's connect these 3 points, which will glow one by one, to these points that define angle ABC. So first point A. Now I'll attach point E to point B. And finally point F to point C. And here I see I have the measure of angle ABC. Now I would like the angle here at angle A to be twice this measure. So I'm going to use the calculator. I'll tap the calculate tool and I'll tap here inside that box. and I'm going to calculate 2 times the measure of ABC. I don't want to just use the angle measure of 84, which is twice 42, because when I drag point C, this angle will change. So I want this to be 2 times, and then I will tap directly on that measure to enter it into my calculation, and tap OK. So here we have twice that measure, which is 83.5, and notice as I drag point C, both measures update dynamically. So now I want to create an angle here with this measure of 2 times the measure of ABC. And to do that, I'm going to use the rotate tool. So I'll tap on that. And here I see the point that I'm going to rotate. This is the center of rotation, and that's the result of rotating by this angle of rotation down here. Actually, while I'm at it, let me make this window a little bigger. I'm going to tap to X out here, or just tap that icon again. And I guess I can't make it bigger, so we'll go with this. Or actually, let me just scroll up a little bit. All right, so I'll tap on the rotate tool. This is the point I'm going to rotate. I'm going to rotate point B. The center of rotation is going to be A. And my angle of rotation is going to be twice the measure of ABC. So I'm going to tap directly on that measure to merge the angle of rotation to it. So I'll tap on that. And now I see here's the result of rotating point B using A as the center and by this angle. So I'm going to construct another ray starting at A and passing through that point. And if I label that point here B prime, or let's actually just call it something friendlier like D, then the measure of DAB, based on the way I just constructed this, is twice the measure of ABC. And here I see my triangle. I can construct a segment here and label this point E. And if I want, I can also construct the interior of AEB to see my triangle. So here is my static triangle, where again I have a measure X and a measure 2X. And I control this triangle by dragging point C. And again, I don't want to spoil this for you, so I'm going to not drag it right now. But if you go to my blog post on page 1 of the post of the web sketch, you can construct this triangle. And if you don't want to do that, on page 2 of the web sketch, there will be a page control at the bottom right. You will see this construction pre-built for you, and you can drag point C to see what happens as the measure of ABC gets larger and larger.